Trigonometric ratios. Fill in the fundamental trigonometric ratios below. Sine, cosine, and tangent. The name of the angle follows the trigonometric function. If the angle is named alpha, the function values become sine alpha, cosine alpha, tan alpha. Alpha plus beta here equals 90 degrees. If the angle is named beta, so this is the one we're talking about now, the function values become sine beta, cosine beta, and tangent beta. If you are given the lengths of 2 or 3 sides of a right triangle, the trigonometric ratios let you find the measures of the acute angles. If you are given one side and an acute angle, trigonometric ratios let you know the lengths of the unknown sides. We expand our definitions to right triangles of any size by noting that the ratio of sides of similar triangles are equal. So here, we can slide this over, and you can see that these two triangles are similar. The opposite side to the adjacent side to the hypotenuse is an equal ratio to sine alpha, cosine alpha, and 1. It follows then that opposite over hypotenuse equals sine alpha over 1 equals sine alpha, and adjacent over hypotenuse equals cosine alpha over 1 equals cosine alpha. There are two acute angles in a right triangle. Let's focus our attention on angle beta. So here we have angle beta up here, and we slide this triangle up to confirm that these triangles are similar. They both have angle beta here. And in these diagrams, the names opposite side and adjacent side are named with respect to beta. So you see this side here is adjacent to beta, and this side here is opposite to beta. So the ratio here, opposite to adjacent to hypotenuse, equals sine beta to cosine beta to 1. It follows that the opposite over hypotenuse equals sine beta over 1 equals sine beta, and adjacent over hypotenuse equals cosine beta over 1, which equals cosine beta. Note that the ratios can be simplified. So here we have sine theta over 1 equals sine theta, cosine theta over 1 equals cosine theta, sine theta over cosine theta equals tan theta. Here we have sine theta over 1 equals opposite side over the hypotenuse, which equals opposite over hypotenuse. Cosine theta over 1 equals adjacent side over hypotenuse, which equals adjacent over hypotenuse. And sine theta over cosine theta equals opposite side over adjacent side, opposite over adjacent. Alright, so here's a little cheat sheet. We have sine theta, which is, here's theta. Sine theta is going to be our opposite side over the hypotenuse. Opposite over hypotenuse. Cosine theta, here I'll color coordinate. Cosine theta is going to be adjacent over hypotenuse. And tan theta is going to be opposite side over adjacent side. These trig ratios are used so often that they are memorized by the expression SOHCAHTOA. So, S-O-H, which stands for sine opposite hypotenuse, ka, because that is cosine adjacent hypotenuse, and toa, tangent is opposite over adjacent. If you get confused by the vowel sounds in SOHCAHTOA, you could also try the mnemonic device below. Some old horse caught another horse taking oats away.